All right, so another way to express three-dimensional coordinates is with what are known as spherical coordinates. And actually, spherical coordinates, sort of like cylindrical coordinates and polar coordinates, we still use that theta, and the theta angle is the same as the theta angle before, but there's also another angle and another piece to it too. Okay. All right, so let's say I've got this point out here in space. So let's pretend that's out front here at the board, but you have to draw it in there. All right, so yeah, like I said, theta is still angle theta, which is the, if I kind of project this, all right, so it's got a certain x value and y value, so let's say we, our x value, y value is out here. Of course, we're not going to use kind of under it, yeah, kind of project it onto the xy plane there. All right, so theta is still the angle, that line, which is the line underneath the point in the xy plane. You're with me there. That's still theta from the positive x-axis. So you still got that angle theta. Okay? Now, so this point's coming out of the board, this value. So then I go straight up from that, okay? So theta's part of it. Here's what the other parts are. If you go from the origin directly to my point, so just go straight to the point. So actually, in actuality, this point we're saying is out here and then up, so we're going straight to that point in space. That's called rho, and that's part of the spherical coordinate. So rho is just the distance from the origin to the point, directly to the point. Okay. Theta, like I said, theta is the same angle as theta in polar and cylindrical. So it's that the angle from the positive x-axis to, and we can still reference this line here, but or this part here, call it line R, which is in polar. That's the R we've been talking about, the xy plane. Same thing. But then we also talk about phi. Sometimes you'll see also this phi. It's a Greek letter, upper and lower case, but this book will use we'll use this one for our purposes. This book. All right. Well, what is phi? Well, phi is the angle. All right. So we've got this point out here, shooting out here. So phi is from the z-axis to that direct line to the point. So phi is right here. So phi is the angle from the positive z-axis and the line between the origin to the point. Okay? It's a lot different, isn't it? That's a whole lot different. We haven't really done anything quite like that before. I mean, we've done theta, but that's what spherical coordinates are. Note here that phi, we're talking about usually just positive angles for it, 0 to pi. Phi angles are 0 to pi. You know, theta can have a whole wide range. I mean, like that one problem we just did was negative pi over 2 to positive pi over 2. So sometimes theta is 0 to 2 pi, but so theta can have negative, but usually with phi, we're talking just 0 to pi, 1/8. All right. Get anything you want with that. Okay, so a couple other notes. Note that, okay, so this right here that I said to go from the XY plane up to that's Z, isn't it? And because of this right triangle right here, Z equals, what would Z equal in terms of phi? Well, because of parallel lines and all that, this is also, if this is phi, this is phi. Right? Because they're alternate interior angles or whatever. That's going way back, isn't it? But anyway, if you look at it, so rho is the hypotenuse. So here's my, I got that right there. So there's my 90. That's Z. This is phi. This is rho. So cosine of phi equals Z over rho. So Z equals rho cosine phi. And then R, this is R, so R is rho sine phi. So that can help us in a minute. All right. But it's just right triangle stuff. Okay? All right. So spherical coordinates, you got, it's usually the order is this. Rho, comma, theta, comma, phi. Rho's first, and then the theta is the second one, and then phi is the third. Rho is a distance, and theta and phi are angles. Okay? So, again, one of the things we'll be converting from spherical, really want to get eventually to Cartesian, and back to vice versa. But let's think spherical, first of all, to cylindrical. All right, so rho, theta, phi, how would that set up to be? Cylindrical is Z, R, theta. R, theta, Z. Well, that's one reason I talked about what I talked about. Good thing, yeah. All right, so theta is theta, so that's no big deal. R would be, like we said, rho sine phi. And then Z is rho cosine phi. Theta is theta. I'm having trouble distinguishing theta and phi here. Well, that helps us to go now, let's think spherical to Cartesian. Well, so now I just need x, y, z. Now I just need to take what I know about Cartesian and cylindrical. I know x is r cosine theta. And theta is okay. R in spherical, though, r sine phi. So I'd have x is r cosine theta, but r is rho sine phi. So x in spherical is rho sine phi cosine theta. Y is r in polar or cylindrical, r sine theta. And so r, again, is r rho sine phi. So the only difference between x and y, because both of them have rho sine phi, is instead of cosine theta, you got sine theta. And then, of course, d is rho sine cosine phi. So spherical to Cartesian is, that's how you do it. Little formula for you right there. Well, you don't need this part, but that's how we got there. But directly to it, there you go. Another helpful equation here. All right, so yeah, again, we've got the right triangle, and Pythagorean theorem still holds. R squared plus z squared would equal rho squared. Well, Cartesian-wise, then we could say, couldn't we, that rho squared equals, what's r squared equal in Cartesian? X squared plus y squared. So rho squared is x squared plus y squared plus z squared. That's another helpful little equation. And I guess another way you could look at it is, yeah, it's the distance from the origin to the point. So rho squared would be the square of that. Anyway. Okay, so here's what they'll have us work on a little bit, maybe. Plot the point with spherical coordinates. It's 2 square root of 2, pi over 4, pi over 3, and then convert it to Cartesian. Probably something I'll have you do. All right, so let's see if we can do it spherical wise. All right, so when we got spherical, this is rho, this is theta, this is phi. Probably, you start with the angles here because rho is just the distance from the origin out to the point. Well, I could go a number of infinitely many ways, let's say, to 2 square root of 2, that distance out, right? There's infinitely many ways I could go. But the angles kind of tell us where we go. All right, so theta is pi over 4. That's the angle in from the positive x-axis, 45 in the XY plane. So I go 45. Phi is the angle from the z-axis. So kind of think here, I've got to be kind of parallel to that. So phi is the angle from the positive z-axis. So I'm angling out pi over 3, which is 60. So I want to go 60 degrees, which is, you know, fairly good amount. And so that kind of sets up my, would look pretty good here, maybe this. That gives me kind of my line to, so that's pi over 3. This is theta, pi over 4. Now, along that line, that's how far I go out to my point. So 2 square root of 2 was about, I don't think that's quite 3, but so I want to just go out to that point. It's just hard, you know, it's hard to get some three-dimensional tools here, we could work with it, but, so it's kind of out of the board here, right there. Okay, so what is it in Cartesian? Well, x, we just said, x is times the rho times sine of phi times cosine of theta. So x here would be 2 square root of 2 times sine of pi over 4, no, pi over 3, cosine of pi over 4. So that would be 2 square root of 2. I know cosine of pi over 4 is square root of 2 over 2. Sine of pi over 3, that's square root of 3 over 2. So one of those 2's cancels, so I got 2 square root of 3 over 2, which, oh, that also, so it's just square root of 3. X would be square root of 3. Y is then rho sine phi cosine, sine of theta, which, oh, in this particular case, 2 square root of 2, sine of phi, I already did that, that's square root of 3 over 2. Sine of pi over 4 is the same as cosine of pi over 4, so with the exact same value. It won't always work that way. And that, in this case, would be the same thing. And then z is shorter, it's just rho cosine phi, so 2 square root of 2 times cosine of pi over 3, right? Which that's just a half, which is just square root of 2. So initial little one. Oh, wait. Yeah, I did that wrong on my paper. Did I do that right? Believe that? Well, so another possibility would be reverse that. Go from Cartesian to spherical. So let's see how that, a little bit of a difference here. So let's convert negative 1, 1, negative square root of 2 to spherical. Okay, well, yeah, that's where this little number right here comes in handy, this little equation. For rho anyway, rho squared equals that, so rho is just going to be the square root of the squares added together, so yeah, just take your square root of all those added, so that's what? Oh, that's nice. 1 plus 1 plus 2. Or 4. Rho is 2. All right, what else we need? Spherical, we need rho, we need theta, and we need phi. Well, theta's the same as in, that's the one thing we have worked with, right, before. Theta is the same as theta and polar and cylindrical. How do we get theta in those cases from, all we need is x and y, right? Because theta is in the xy plane. Tangent of theta is y over x. So tangent of theta equals 1 over negative 1, which is 1. Okay. Okay, so what do we have there? Well, the only problem is your tangent inverse is directly there. It's tangent inverse would be what, negative pi over 4, right? But is that really the one we want? Well, just look at the point projected onto the xy plane. In the xy plane, we're talking negative 1, positive 1. That gives me a quadrant 4. I need this, if you will, this angle right here. Pi minus pi over 4, 3 pi over 4. So yeah, you have to be a little careful with the tangent inverse or using any time you have sine inverse or cosine inverse. Is that okay? Does everybody see what I'm doing? Since the point's negative 1, 1, I'm in quadrant, in the xy plane, I'm in quadrant 2, not quadrant. This tangent inverse would be quadrant. So that would be theta right there. All right, then, so I've got rho, and I've got theta. What does that leave? Phi? Well, since I have rho, and I need phi, let's look at z. What is z? Z is rho cosine phi. I've got z, and I've got rho. Yeah, I'm in trouble with theta and phi here. That's phi. So negative square root of 2 over 2 is cosine phi. And the good news is on this, remember phi goes from 0 to pi. Cosine inverse does the same. And so this we can say phi is cosine inverse, whatever cosine inverse of negative square root of 2 over 2 is. Because they have the same parameters. So that's a, also, what is that? We're back on board. Be quadrant 2 also. Anyway, bars, cosine, sorry. All right. Well,